Hello and welcome back to my Java tutorial series. You can see our product from the last episode, which is more than just that class, but let us just dive straight in because now we're going to focus on maybe a small series of episodes dedicated to showing you all about generics and generic types and etc. Now we're just going to set up our stuff we do every time. Every single time. Yeah. So now, what I'm going to do after I set up our main method, we're going to do public static main. No, it's void main. Everyone messes that up at some point or another, or every single time. But here, we're just going to make two classes. We're going to call the first one not generic. And in not generic, we're going to create a simple thing. We're going to do, how about a private object key and a private object value. So then, we're also going to do a constructor, which will be public not generic object var1 object. Actually, let's stick with the key value thing. So now we're just gonna say key this dot key equals key, standard set stuff, and then we're just gonna do a public object get key. Just return this dot key, and you don't really need to put this there because there isn't anything to get confused with, but just in case, get value. It's always a good just in case thing. So now we have a basic class set up. Basically, it saves two objects. Now the main thing is we're not going to be storing objects in here. We're going to actually be storing, we're not going to be storing objects, we're going to be storing subsets of objects. So let's just do a public static string, how about we'll do key1 equals, I'm the first key. Then I'll do a public static integer value1 equals 5. So now I have two things up here. Now we're going to make a new thing. We're going to do a public static not generic not gen equals new not generic, and we'll just do key1 value1. So that works perfectly. And what if we wanted to copy this over to something? So let's say we want integer, or a new integer, and we'll just call this int1 equals not gen dot get value. Now you see, this is a problem because this is going to return an object, because for get value, it's going to return an object. I mean, of course, it's going to return an integer, because it is, but the only problem is we have to actually typecast it to integer. So now we're just going to do a quick system.out.println int1. Now, of course, this is a very small thing we're doing. Of course, we know we're giving it an integer as a thing, so we should get an integer back when we request it, so this should obviously be printing out a 5. But if by any chance we're actually doing something that we shouldn't be doing, like imagine if we set it as a string, and we typecast this to a string. String is a type of object, so this isn't going to complain at all, but when we actually go back to it and run it, we get an exception, because class cast exception. You can't cast an integer to a string, because right here, this is going to return an object. And it's going to say, hey, here's an object. Oh, you want to convert it to a string? Oh, sure, I'll let you do that, since string's a subset of object. But right now, since the value of this is an integer, it doesn't know that. All it knows is it's returning an object. So you're trying to cast it as something it's not. So in larger programs, it might get confusing in how you're doing that. Now this is where generic is going to help us out. So let's create a new class and call it isGeneric, because generic is a bit too generic for a class name that uses generics. Right? So basically, after this, generics mainly operate around the thing that they use these little greater than or less than signs. So basically we're going to put in T. Actually, we're going to put KV, which stands for key and value. So we're going to do a private K, which is a type now, key, and we're going to do a private V, value. So now we have these. Now we have K is obviously not a class that we have, but I'll show you what all this means later. We're just going to do, you know, the public static is, wait, no, not static, am I crazy? Only a little. Public is generic. We'll just pass a K key and a V value. That should work perfectly. Yes, it does. So what we're going to do is just going to, you know, this dot key equals key, and this dot value equals value. Now here's where it gets. We get public key K get key, and we're going to do return this dot key, which is of type K, which is a generic type. I mean, K is obviously not a real object, and V is not a real object yet, but it is a generic type that we can easily return and create new objects of. But you'll see how we determine what those are. We'll just do public V get value, and we'll do return this dot value. So now we get to something. We'll just create a public, the same exact thing essentially, but we're gonna obviously call it isGeneric, and we're going to put the same thing after this like we did at the beginning of this class. So obviously it accepts basically any object, but it has to be an actual object. So we're gonna say it's gonna have a string as a key, and it's going to have an integer as a value. So that's perfect right there. And we're just gonna, you know, change this to isGen, and we're gonna change it to isGeneric again. We're gonna say key 1 and value 1, but right now it's yellow because it says, you know, is a raw type. Generics are raw types when you don't put these carets here. Yeah, in between these greater than or less than signs. If you don't put anything there, it's still fine, but it'll be yellow because generic types do want you to outline, you know, what it's putting in there, because that's the whole point of generic types. So basically, we can completely copy and paste this over here to, you know, it's a new generic that also has those things. But if you're doing a setup like this, where this will obviously be able to know what it is based on this, you can just put the empty carets. This is called diamond notation. You can tell because it looks like a diamond, and basically it won't give you any errors because it knows when it has a diamond. It'll just look over here and it's like, hey, let's just make this a new one with the exact same setup. So now with the same thing, we can do, we can change that back to integer just so we don't get errors. But this time, let's do integer int2 equals isGen dot get value. Now when we hover over get value, you see, whoa, it's returning an integer. You know, when we set it in the class, we told it just to return V. This is supposed to return V. But hey, it's not returning V over here, it's returning an integer. That's because when we set this up, K means string, and V means integer. So basically, if you go through here in this instantiation of this generic type, just replace every K with string and every V with integer, and that's basically how it works. So why is that getting an error? Oh yeah, because it's not used. So this time you don't have to typecast it at all, because it's a generic type, it knows exactly what you're doing. So it's not like you can't incorrectly typecast it. So if you do that, it's going to output it, which is 5. We can also do string, and we'll just say get key. And we'll just change this to string 1. Just for sake's sake. No, string 1, not the generic type. Okay, so now if we print this, it should say, I'm the first key. Well, you're really not. You're the second one, but that doesn't matter because we forgive you. So you see, it's a lot easier because one, you don't have to typecast, and two, you won't have any dangers of typecasting the wrong way. So there are several other ways to this. I mean, you can do like anything in here. It doesn't have to be just string or integer. It can be literally any other object, including other generic types, since those, those are obviously objects. But what we should do now, there are several other things you can do with generic types, and there are some generic types you can set in that are really useful. We might get those in later episodes, because right now we just want to set up the whole foundation for generic types. So I think we can handle wildcards in the next episode. Yes, wildcards are interesting. Right now we can do inheritance. So so basically, integer extends object, and string extends object. But the thing is, if you were to make like an isGeneric string integer, that wouldn't be compatible with like, well, okay, one second. I should probably just set up a example for you. That would probably be the best idea. So let's just set up a, so if you create a, sorry for being a bit slow on the ball right here, but let's do is public static object obj1, object1 equals new object, empty, what the hell, sorry, and then a public static integer 1 equals new, I know we could set it to a literal, but let's just not for now, 19. See, what we could do, we could set object1, well, let's see if we can. We can't, or at least shouldn't be able to set object. Okay, we can set object to the integer, because integer is an object. You get it? We can set an object to an integer because an integer is an object. If we try to switch this around and try to make it an integer equal to an object, we can't do that because an object is not an integer. An object is not a type of integer. That doesn't make sense. What is your problem over here? You're going to tell me, or you're just going to be silent? Yeah. Yeah, because it thinks we're doing something else over here. But obviously, an object is not a type of integer, so you can't set it to that. So you can only set things to things that might extend them. So we can easily do that, except we can't do it here. We have to do it in here. So, oh yeah, here's where we would do it really. So now we can do obj1, and that should give us the error. Okay, so cannot convert from object to integer, but you can convert from integer to object, because an integer is a type of object. So that works perfectly fine. So another way to go about this is that when you make a generic type, let's make a more simple generic type. Let's just set this to we'll just edit this one because we don't need it. No, we'll just keep it there since when I post the source code. And we'll just create a new class and call it single generic. This time we're just going to create a simple one, and it's going to have just T, which stands for type. There are certain notations that programmers tend to stay to with when making generic types. There's certain capital letters like K is key, V is value, T is type. There are a couple other ones, but you can just look those up. So we're just going to make, single generic T type this dot type equals type as always, and we can just do public T get type return this dot type, your standard thing, and then we'll do just a public void set type t type. This dot type equals type. There. So now we can set and get this. So basically, if we made a new thing, which would be a single generic, let's just make a public of, we'll make it over here, because we don't really care. A public static single generic. We'll just make it hold an integer for whatever case. We'll just do sgen equals new single generic. If I spell it right, of course I always have a bit of a spelling problem, unfortunately. Generic, did I spell it wrong again? Oh yeah, I need to bind it to a type. So we'll just say new integer 3. 3 is a nice number. It's odd, but it's still a nice number, nevertheless. So basically, we try to do something here. So basically, yeah, that's it. We can easily just system.out.println sgen.getType, which of course will return an integer object. So we can just print out, you real quick, see 3. But what we want to do, let's make a method and say public static get type. And we're going to say it accepts a single generic of type number. And we'll just say sgen. Oh yeah, public static number. I think that'll work. Oh yeah, because we have to return it. So return sgen.getType. So this will only, if you have, so let's just make another one of these. And we'll say it accepts a number. We'll just make these 1 and 2. And this, an integer is not a number. So let's see if we can do new number. I don't think we can. Let me think. Cannot, yeah, you can't instantiate number. Let's just, we don't really need a number one. Okay, so basically, you know that if we, we'll probably make another one eventually. So you know, if we actually tried, if this was like number, you could still input integer for number, because integer extends number. So you can use integer in places when it needs number. But the thing is, a generic type that requires a number is not subclassed by a generic type that has an integer. So let's just make, we'll put this into one line so it looks neat. So get gen number. And then in another form we'll do public static number get it'll just be get number. And you'll just have to put in a number, num, and it'll just return num. It doesn't even make sense. It doesn't have to though. So basically, yeah, it's a completely redundant method, but that's besides the point. So if we do public, well no, we're just using the method. So let's just say number num1 equals get number. We can even use value 1. So it'll return a number, and I think we can print out the number. I mean, you can't instantiate number, but you can definitely print out a number. What are you doing? I don't like you. Get away. But no, we can copy that, and we can paste it here, and we can print it out. Here's helping, and it prints out a 5. So that's perfect. You can pass that. It's asking for a number, but since integer extends number, you can do that. But if we try to do get gen number, well, we should do number num2 equals get gen number. Now, if we try to pass sgen1, we'll get an error. Or at least I sure hope we do. The method getNumber single generic number is not applicable for the argument single generic integer. Because while integer might extend number, when it comes to generic types, the generic type doesn't extend anything. I mean, generic type classes can extend other classes, but when you're passing some things inside of what the generic type holds, they don't extend each other. I mean, there are other ways to make it possible via wildcards, but those will be in the next episode. But just so I can show you, if we did do a public static single generic number sgen2, we don't have to declare it because we can't declare it because we can't instantiate number. But if we just did that, then it would work perfectly. It wouldn't return. It would give us a null pointer exception if we tried to print this out because it's null, at least, or it might, yeah, it's a null pointer exception because this is null. But yeah, but it still works. You see, the compiler, the IDE isn't getting an error because it is a single generic number, which was what it's asking for. So that's it for this episode on, I'll just call it basic generics. Since we did go over more, I was going to call it intro to generics. But you get it. So, I will see you tomorrow, and good programming to you.